Today we are doing lesson 5.4, solving proportions. Our I can statement is I can use different strategies to solve proportions. So we've looked already at using mental math to solve proportions. Today we're going to be continuing with that strategy and looking at some other strategies for solving proportions as well. So some of those will be using the multiplication property of equality, using the cross products property, using a tape diagram, a ratio table, or a unit rate. You can use all of these for solving proportions, and then just depending on the problem, some strategies are better than others. So let's take a look at proportions here. We have a picture of a balance because the two sides of a proportion are equal, and you can think about those like equivalent fractions. If we thought of these as fractions, 5/15 means the same thing as 10 over 30. We know one way we could compare these is if we simplify them, they would both simplify to 1/3. 5 divided by 5, 15 divided by 5, and over here if we divide by 10, we would get this one to be 1/3 as well. So they're like equivalent fractions. They mean the same thing on both sides. Okay, so if we are missing part, like this proportion here, 5 over 15 equals x over 30, we can use a lot of different strategies to solve it. I always like to start by looking for multiplication patterns, either side to side or up to down. If you see one of those patterns, it's going to be an easy and fast way to solve your proportion. This one happens to have both of those patterns. So side to side, if you notice 15 times 2 equals 30, you could do 5 times 2 to get that number 10 that we see up here at the top. I could have also done a up and down pattern. I could have said, okay, I know 15 divided by 3 equals 5. So I can do 30 divided by 3 and get my answer of 10. So looking for multiplication or division patterns that are easy to do in your head is a great way of solving proportions. However, not always. You're not always going to see an easy multiplication pattern from side to side or up to down. So when we do that, a great strategy to do is cross multiply. When we were checking things in proportions, we looked at how those cross products are equal. If it's proportional, when I multiply on the diagonal, this diagonal is going to equal the same thing as this diagonal. So that means when we are missing one, we can use that information about cross products to help us set up and solve an equation to find our missing value. So for example here, 21 times x is 21x. And then I would do 6 times 14 on the other side. Because they're proportional, those cross products are going to be equal. Now I don't know 6 times 14 off the top of my head, so I'm going to do that work off to the side. 4 times 6 is 24. 6 times 1 is 6 plus 2 is 8. So now I have 21x equals 84. Then I need to divide both sides by 21. And I'm going to get x equals 4. 21 goes into 84 4 times exactly. All right, go ahead and pause the video and try these two problems on your own. Okay, let's check our answers. So first one, I have 4 over 6. 4 is to 6 as 3 is to x. I don't see an easy multiplication pattern side to side or up or down. So I'm going to do cross products. 4 times x is 4x. 6 times 3 is 18. To get x by itself, we divide by the number in front of it. So now we're going to do 18 divided by 4. It doesn't divide evenly, so I'm going to go ahead and just write out our long division. 4 times 4 is 16. And I have 2 left over. Let's see, I'll do a decimal. You could do a mixed number too. 4 goes into 25 times exactly. So 4.5 is our answer for this one. Okay, let's look at this next one. I don't see an easy multiplication side to side there's a whole number that I could do 4 times to get to 10. But I do see a multiplication pattern up and down. I notice that if I take my top number and I multiply by 3, I get the bottom number. 4 times 3 is 12. which means that pattern is going to be true on this side as well. 10 times 3 is going to give us R equals 30. You can do cross products on this one as well. Okay, 2 more to try on your own. Go ahead and pause the video and try them. Okay, let's check our answers. So I have 3 is to 4 as y is to 9. No easy multiplication patterns up and down or side to side. So we're going to do cross products. 4 times y is 4y. 3 times 9 is 27. I divide both sides by 4. To cancel out the times 4, so I have y by itself. Okay, 27 divided by 4. I'm going to do that off to the side. 4 goes into 27 6 times. 6 times 4 is 24. I have 3 left over. I'm going to just write that as a mixed number, 6 and 3/4. That did not write very neatly, so I'm going to try it again so you can actually read what I'm writing. 6 and 3/4. If you wanted to do the division out to get a decimal, it would be 6 and 75/100. That is fine too. All right, let's take a look at this last one. Again, I don't see a multiplication pattern up and down or side to side, so we're going to do cross products. 6 times z is 6z, 5 times 8 is 40. I'm going to divide both sides by 6. 6 divided by 6 is 1, leaves me with z. Now I need to do 40 divided by 6. Goes in 6 times. We get 4 left over. If I wanted to do a mixed number, that would be 6 and 4/6. If I'm doing mixed numbers, I do need simplest form, so that would be 6 and 2/3. If I was going to divide it out, I would get 6/10 repeating. Either one of those is okay. As always, make sure you're writing down your work to support your calculations. All right, let's take a look at this next one. So it says the graph shows the toll y due on a turnpike for driving X miles. Your toll is $7.50. How many kilometers did you drive? And then they give you this extra information. They're approximately 1.16 kilometers in a mile. So I'm going to use this for half of my proportion. All right, so I'm going to do 1.16 kilometers for 1 mile. Okay, and then it tells us here that X is what the X and Y is showing how much we paid for a certain number of miles. And it tells us our total is $7.50. So here's $7.50. That matches up with 100 miles. And then I want to know how many kilometers that is. All right, let's see. I'm going to go ahead and do cross products on this one. 1 times X is X. 100 times 1.16 is 116. My label is going to be kilometers. All right. Ratio tables. We've done some work with ratio tables already. Ratio tables are good for comparing different proportional amounts. Can be good for mental math work as well. So let's go ahead and do our ratio tables for this one. So here's the situation. 1 pack of gum has 18 sticks. And I want to know how many sticks are in each of these other packs of gum. So we'll look at some different patterns here. Okay, so if I have 2 packs of gum, that's twice as many as my first one. So I could do 18 times 2 and give myself 36. That would be 36 sticks of gum. Now to get to 4 packs of gum, I could say, okay, well, I'm going to double what I had and do this times 2. And then I could do 36 times 2. I know 36 times 2 is 72. So that would work. Okay. Let's see, from 4 to 8. I could do times 2 again, doubling our amount. Okay, so 72 times 2 would be 144. Here I can't do times 2. That doesn't work. But I can go back to my original one and say, hey, I'm going to compare the 1 now here. That's times 10 on the top. So I can do times 10 on the bottom. 18 times 10 is 180. And then I could get to 9. So I could do 8 sticks plus 1 stick more. I could subtract out what 1 pack is, which is what I'm going to do. So if I had 10 packs and I took away 1 pack's worth of gum, it would give me 9. So if I take away 1 pack's worth of sticks, then I'm going to have 162. So there are lots of different ways to use ratio tables. Here our pattern was this number times 18. You can look from column to column. You can add or subtract as long as the top number and the bottom number stay in that same ratio as what they started with. All right, so tape diagrams. Tape diagrams are something else to give you a visual of a situation for a ratio or proportion type problem. So here's our tape diagram. The problem is a punch recipe calls for 5-part ginger ale to 2 parts orange juice. If you need to make 28 cups for the party, how much of each ingredient is needed? So 5 parts ginger ale, there are 1, 2, 3, 4, 5 boxes here. And then 2 parts orange juice, 1, 2. And all together they're going to equal 28. So if I add those boxes together, I had 5 boxes of ginger ale and 2 boxes for the orange juice. That's going to be 7 boxes, 7 total things. And all together they're going to equal 28 cups. So to figure that out, I'm going to do 28, my cups, divided by 7, and I'm going to get 4. That means each one of these boxes is worth 4 cups. So all of those 7 boxes together equal 28 cups of liquid. That means there's 4 cups of liquid in each one. Now that I have that, I can use this information to figure out how much is needed for both. So here I had 5 boxes. Each one is worth 4 cups. So I have 20 cups of ginger ale. And then I have 2 boxes. Each is worth 4 cups. So that's going to be 8 cups of orange juice. And then hopefully that makes sense. 20 cups ginger ale plus the 8 cups of orange juice does give us 28 cups of punch. All right, sometimes using a unit rate is helpful for solving a proportion. So in this situation, if 2 pounds of cheese costs $16, how much will 9 pounds cost? Well, if I want to try to do this mentally in my head so I don't have to do the long division or longhand multiplication for 9 times 16, I can think, well, if 2 pounds is $16, 1 pound's going to be $8. I get that by dividing my original number by 2. 2 divided by 2 is 1. So 16 divided by 2 gives me 8. And now that I know 1 pound costs $8, it's pretty easy for me to do in my head how much 9 pounds costs, because it's going to cost 9 times as much. So I can do 8 times 9 and get a cost of $72. All right, so let's take a look at our next one here. So setting up proportions for story problems. Lots of ways to do this, and we looked at some of them in 5.3, but you do have to make sure that you are lining up your labels. Same labels in the numerator, same labels in the denominator. So here's this particular one. J&A department store is selling 3 pairs of children's socks for $5. Mrs. Wagner wants to buy a dozen pair of socks. How much will this cost? Dozen pairs means 12. All right, so here's my original information. 3 pairs equals $5. It doesn't really matter which one goes on the top and which one goes on the bottom. I just chose to keep it in the same order in the first sentence. So now I want to know a dozen, 12 pairs of socks, and how much that costs. Now I could do cross products, but I do see a multiplication pattern, so I'm going to go with that. 3 pairs times 4 is going to give me 12 pairs. So I want 4 times the amount of socks, which means I'm going to have 4 times the amount of cost. $5 times 4 gives me $20. All right, now I have some problems for you to try on your own. So it says solve the problem in as many ways as you can. So you're going to try it in at least 2 different ways. So go ahead and pause the video, try this problem. Okay, so let's take a look at a couple strategies for doing this one. So I'll start with a proportion to caterpillars. And 5 leaves. And we want to know for 30 caterpillars how many leaves. Okay, so let's see. I've set up my proportion. I do see a multiplication pattern, which would be times 15. 2 times 15 is 30. So I can do 5 times 15, which I know is 75. If you don't know that, then you could always do the work off to the side. Okay, so that's one way to do it. You could have also written the same proportion. I'm just going to use one letter instead of the whole word. 2 caterpillars, 5 leaves, 30 caterpillars, X leaves. And I could have done cross products. I could have said 2 times X is 2X. 5 times 30 is 150. And then I'm going to divide both sides by 2. And I still get X equals 75 leaves. Okay, here's another one. Try to solve it in more than one way. Go ahead and pause the video and try it on your own. All right, let's look at this one together and check our answers. So it says a cookie recipe calls for 3 cups of chocolate chips and 2 cups of peanut butter. How many cups of chocolate chips will be needed if 9 cups of peanut butter are used? Okay, so I'll start with a proportion on this one. 3 cups chocolate chips, 2 cups peanut butter. And then I want to know how many cups of chocolate chip for 9 cups of peanut butter. That is supposed to be a P. All right. Make sure you have the same labels on the top and on the bottom. Okay, so let's see. I'll do cross products as my strategy. 2 times X is 2X. 3 times 9 is 27. When I divide 27 divided by 2, I get 13.5 cups of chocolate chips. Let's see, I'll do a different strategy. This time I'm going to do a ratio table. So chocolate chips, peanut butter. We knew 3 cups of chocolate chips for 2 cups of peanut butter. We don't know how many chocolate chips. And then 9. Let's see, for my ratio table I could have said, okay, I know 2 times 4.5 equals 9. So I would do 3 times 4.5. And then I'm going to do the work. 4.5 times 3. 5 times 3 is 15. 4 times 3 is 12 plus 1 is 13. 1 decimal in the problem, 1 decimal in the answer. Yep, still got that same answer of 13.5 cups. All right, last one. Go ahead and pause the video and try this one. Okay, let's check our answers. To make perfect purple paint, mix 2 cups of blue paint with 3 cups of red paint. If you want to make 20 cups of perfect purple paint, how much how many cups of each color do you need? All right, this is a good one for a tape diagram, so that's going to be the strategy that I use. Okay, so let's see. If I do my tape diagram, I have blue, and it's 2 cups, so I'm going to do 2 little rectangles. 3 cups of red. So I'm going to do 3 rectangles. Make my rectangles look about equal in size. Okay, and then all together I know it needs to equal 20. So I've got 5 boxes here. I'm going to do 20 divided by 5 boxes. That gives me 4. So I need 4 cups for each box. Then I have to add. So my blue, I'm going to need 8 cups. And red, I'm going to need 12 cups. So my answer is 8 cups of blue and 12 cups of red. So that's one strategy, tape diagram. I'm also going to do a ratio table. We looked at this type of problem with a ratio table in 5.1. Because this one has 3 parts, this is going to be a 3-column ratio table. 1 column for each one of my colors. So I have blue, I have red, and when I mix them, I get purple. We started with 2 cups of blue and 3 cups of red. We want them to equal 20 cups of purple at the end. So one batch of paint would give us 5 cups. In order to get 20 cups, we would have to take our amounts and times by 4. And we'd have to do that for every value. 2 times 4 is 8. 3 times 4 is 12. 8 plus 12 does equal a total of 20 cups. So 8 cups blue, 12 cups red.